Hello, Assalamualaikum. This is Chemistry Form 4 videos on rate of reaction on subtopic 7.2 factors affect the rate of reaction. Okay, so we have a few factors that affect the rate of reaction. They are size of solid reactants, concentration of liquid reactant, temperature, presence of catalyst, and pressure of gaseous reactant. Okay, for size of reactant, the smaller the size of solid reactant, the larger the total surface area. Okay, if we compare these three, okay, solid reactant with fixed mass, okay, let's say the mass is equal. So the total surface area are different for different size of reactant. Okay, for example, this one with the bigger size, 2 centimeter, the length, the width, the height. Okay, so the total surface area is 24 centimeter cube. 24 centimeter squared. Okay, so if we compare, if we crush this cube into a smaller size like this one, the width is 1, the length is 1, the length is 2, the height is 2, which is smaller than the first one. So the total surface area is 32 centimeters squared. Okay, see the difference of total surface area. And this one we divide into smaller size, and the total surface area is 40 centimeter squared. So from here we know that the smaller the size of solid, the larger the total surface area. Okay. Okay, so we have experiment 7.1 to study the effect of size of reactant on the rate of reaction. Okay, so this is the setup of apparatus for this experiment. In this experiment, we use hydrochloric acid and marble chip. Marble chip is calcium carbonate. Okay, so we repeat the experiment. We do this experiment twice. The first one with maybe a larger size of marble chip, maybe in lump. And second experiment, we repeat the experiment by using smaller size of marble chip, maybe powder. Okay. So after we do the experiment and we analyze the data, we got that the total volume of gas collected here showed in this graph. Total volume of gas collected, because when hydrochloric acid react with marble chip, it will produce carbon dioxide gas. So we measure volume of carbon dioxide gas here in this burette. Okay. The total volume of carbon dioxide gas against time increase. Okay, show the increase, and then finally become constant here. Where in experiment, let's say experiment 2, we use powder. Okay, experiment 2 we use powder. In this experiment 2 shows that the rate of reaction is higher than experiment 1. Here. Because of the gradient is of the tangent is a gradient of the curve is slopey compared to experiment 1, which is lump. Okay, so we got that the smaller the size of reactant, the higher the rate of reaction. Okay, second factor is concentration for liquid reactant. Okay, the higher the concentration of a liquid, the higher the number of particles per unit volume. So this diagram shows the difference in concentration. This one is low concentration, this one is high concentration of liquid. Okay, So if we notice that the number of particle, when low concentration, the number of particle is low. For high concentration, the number of particle is higher. Okay, so different concentration will affect the rate of reaction. Okay, this is the experiment to investigate the effect of concentration of reactant on the rate of reaction. Okay, so we use sodium thiosulfate, look at the chemical formula here, and sulfuric acid. When sodium thiosulfate react with sulfuric acid, it will produce sulfur. Okay, the color of sulfur is yellow. So slowly the sulfur will form, and finally this is mark X. Okay, finally we cannot see the mark X. Okay, so the time taken when mark X disappear from sight is recorded. So we got this graph. Okay, so from this graph we know that the higher the concentration, the higher the rate of reaction. And next is temperature. The higher the temperature of reactant, the higher the kinetic energy of the particles. So this is the experiment to investigate the effect of temperature on the rate of reaction. Okay, same as experiment 7.2 just now, but the manipulated variable here is the temperature. Okay, so we heat the reactant first. Okay, and then we add these two reactants, and again we record the time taken for mark X to disappear, and we got that the temperature from this graph, if the temperature is higher, the rate of reaction is higher. Next is presence of catalyst. Okay, what is catalyst? Catalysts are chemical substances that alter the rate of chemical reactions without undergoing any chemical changes at the end of the reaction. So with the presence of catalyst, it will provide alternative pathway with lower activation energy. Okay. So this is the experiment to investigate the effect of catalyst on the rate of reaction. So we use, in this experiment, we use hydrogen peroxide, 5 cm³ of 20 volume hydrogen peroxide solution in both set. But in one set, okay, we add manganese 4 oxide. This is the catalyst for decomposition of hydrogen peroxide solution. So we notice that after we add manganese 4 oxide to hydrogen peroxide, then we test with a glowing wooden splinter. We know that decomposition of hydrogen peroxide will produce oxygen gas. So suppose oxygen gas will ignite the glowing wooden splinter. Okay, then we test both test tube with glowing wooden splinter. So what happened is in test tube 2, the glowing wooden splinter ignites brightly because a lot of oxygen gas produced. For test tube 1, maybe the glowing wooden splinter maybe ignites but dimly, or maybe doesn't ignite at all because of low oxygen gas produced. Okay, we actually have another one factor that affect the rate of reaction, which is pressure. But this pressure is used for reaction that involving gas only. So it will affect the rate of reaction when higher pressure is applied to a gaseous reactant. Okay, that's all from me. Thank you. See you on my next video. Bye.